So I'm going to be telling you about the Cuddly Throwable Application Server. But before I start, let me tell you a little bit about myself to explain why I worked on the Cuddly Throwable Application Server. My name's Holly Cummins. I work for IBM. I've been with IBM my whole career, which is 15 years now. Because IBM's a big company, so I've worked at the top of the stack, at the bottom of the stack, various points in between. But most of my career, I've been working on one aspect or another of WebSphere. I've written a book because WebSphere is built on OSGI. OSGI makes things good. So I've written a book called Enterprise OSGI in Action, which it was a few years ago now, but I'm still kind of excited that I've written a book. So I still have it on my slides. What I do now is I'm based in London and I work in the Bluemix garage, which is quite a new and different part of IBM. So what's the Bluemix garage? Well, First tip, it's not actually a garage. I think some of our staff, they still have conversations with their parents that sort of go along the lines of, Mum, Dad, I've moved to the Bluemix garage. Oh, I didn't think you worked in mechanics. No, I don't, it's okay. We're just a garage because we're cooler. So what we do is we're really all about innovation, and we're about combining the best of the startup world with the best of a big company like IBM. So we can draw on the resources of IBM, but then we can move in a quite nimble way, and we have free beer on site, which the rest of IBM don't have, because we're based in WeWork. So if you would like to know more, do go to that URL or just Google for Bluemix Garage. So I'm going to be talking about small computers, and we're quite used to small computers now. And to sort of realize how amazing where we are with computers is, it's useful to look back, because this was a quote from Popular Mechanics, and that was in about 1946. So a long time ago in computer terms, but only 60 years ago really, so our grandparents' generation. And they said, in the future, in the bright, bold future, computers may weigh no more than 1.5 tons. And Thomas Watson, who was one of the, in the IBM dynasty, he said, I think there's a world market for maybe 5 computers. And this statement, it's so easy to laugh at now, because when I came here, I had 4 computers in my bag. I think probably most of us just carry around, that many computers. But he was actually correct with this for 10 years. And I think if any of us would make a technology prediction that was correct for 10 years, we'd be, signing up to Gartner because we think we were amazing prophets. So it's sort of ridiculous now, but in context, it was actually a pretty sensible prediction. And the reason it made sense was because back then, computers were incredibly expensive. They were incredibly big. They were incredibly skilled and specialized, and they took a whole room, and there was physical bugs that broke them. Whereas now, we're really in this era of ubiquitous computing. So computers are everywhere. I bought a fridge years ago, and it had a computer in it, and it worked really well until the computer just started beeping randomly, and there was no physical change that you could make to this fridge to make it stop beeping, because the computer in the fridge said no, basically. And so my new fridge, it doesn't have a computer in it. So we're still ways off the bright, bold future in that sense. But cars as well, there's more code in a car now than there is in a computer even of a few years ago. And you can buy cars that will allow you to tweet while you're driving because it's built into the car. I still haven't decided if this is a good idea or not. I think it's a terrible idea, but what do I know? You can get toasters. I don't think these ever went to production, which makes me sad because I'm terrible at looking at the window. But you can get toasters that connect to the internet, get the weather forecast for the day, and then burn it onto your toast. So if you see the little sun symbol, you know that you don't need to bring the umbrella. Washing machines, again, lots of computers and washing machines, and most importantly, of course, tablets and phones. When we talk about a phone now, the idea that we might use it to actually speak to someone by voice is kind of the last thing in our minds. That's not what we use telephones for. That's not what telephones are for. But that's a really big change, even from just a few years ago, because now a phone is a small computer, whereas before a phone was a thing that you talked on. But things are still changing, with the exception perhaps of the weather toaster and the tweeting car and the telephone. A lot of the fridge, let's take the fridge. That was really an isolated piece of equipment. It didn't talk to anything else. It didn't make any decisions about what I should have for dinner or whether I needed to buy groceries. But that was a few years ago. Now, when we talk about smart fridges, that's the kind of thing we're talking about. We're talking about these devices that are so small and so ubiquitous that they can just have all the computational power our parents could have dreamed of, talking to each other in order to enable quite interesting behaviors that hopefully are good behaviors. So, how many of you, the starting point is, how many of you are interested in the Internet of Things? About half of you. For the other half, I'm really sorry, but Trisha's going to be amazing. So, for the half of you who are interested in the Internet of Things, how many of you are interested because you're doing it for your day job, or your work is really interested in it? Not a single hand. So you'll be reassured to know that I've given this talk many times, and the most hands I've ever had is 1 for that question. Because all of the rest of us are going, it's so cool and it's so fun, and you plug it in and there's lights and you can make it small and you can do stuff with it. So we've done the poll. We know where you are. So I have to confess that IBM, they have a big business in the Internet of Things. They're a real leader in that space. They've invested huge amounts in it, driving a lot of the great technologies. That's not the bit of IBM I work in. So I've given lots of talks, sometimes to general groups like this, sometimes to more specialist ones. So about a year ago, I spoke at the Internet of Things Stockholm meetup. And I have to tell you, I was so uncomfortable about it because I thought, I'm a hobbyist and everyone else in the room is actually doing it for a living. Why am I talking to them instead of the other way around? And that's a little bit obscured, but you can see, actually you can't see it all. That email is an email I just got asking me to speak at Building IoT London. And I had that same reaction where I thought, I'm really happy to speak about IoT to people who know nothing about IoT, that's okay. But if people in the audience know about IoT, no, just don't do it. So that brings me to a slight digression, which is imposter syndrome. That's something that affects a lot of people, but particularly women. And it's really important to be aware of, because I still feel so uncomfortable talking about the Internet of Things because I know nothing about the Internet of Things, and I'm just waiting. I'm stood up here going, and then they're going to find out, and it's going to be terrible. And the funny thing about imposter syndrome is the more positive feedback you get, sometimes the worse it gets. So when I get invited to speak about the Internet of Things, I think, oh gosh, this is a disaster, they're really going to find out. And if someone says, oh yeah, Holly, she speaks really well on the Internet of Things, I think, no, that's just building up more. It's going to be worse when they find out. So now that I've lowered your expectations. But my day job, until quite recently, was in WebSphere, as I said, and that's really where I got into the Internet of Things, because we did IBM WebSphere, very powerful, very enterprisey, really good for ops, all of the features that all of our customers have ever asked for, which, because we're IBM, is quite a lot, so it ended up being rather large. And we said, well, what can we do to make it a bit more suitable as a development environment as well as a runtime environment or a deployment environment? So we made it quite small and quite light. We completely redid it. It was an interesting project in terms of culture and agile. What we did is we said we couldn't break the compatibility, but we had to completely gut it. So what did we do? We changed the kernel, but then all of the libraries we kept the same, and we just put little adapter shims on. And that meant that the customer experience config was different, but the customer experience in terms of if you wrote a JPA application, it was going to behave the same way. So it was a lot less scary for our customers, but it meant that we could have these qualities of service that we needed, like fast startup, being able to distribute it without taking 2 gigs, that kind of thing. So we did this, and we were so pleased with what we'd done because it was really quite cool. And we got a bit overexcited. So we realized that because it was so small, it could run on Raspberry Pis. So we were now everybody does it, but my colleague Simon was the first person to put an application server on a Raspberry Pi. And it was really cool, and we gave it away on USB sticks, and we did all sorts of stuff. So the Raspberry Pi, very cool, he did that. And then I came back from maternity leave, and I said, well, Simon's done WebSphere on Raspberry Pis, what can I do? Well, I thought, Raspberry Pi, it's a little bit static, it just doesn't do much. So I said, I can do better, because I can buy a PC Arduino, which has Internet of Things pins, or well, Arduino pins, and it's a really cheap bit of kit. It's, £60. What I did was I took the PC Arduino And I put Liberty on the PC Arduino, which is not the normal Internet of Things architecture. I connected it up to the sensors, and then I could have my laptop, my application, my phone, and I could talk to it. So I said, what can I do to make this happen? Well, I wanted something that was more dynamic than just a Raspberry Pi sat at the front of the room. But if you have something moving around the room, it's a bit vulnerable. So I said, well, what can I do to protect this on its travels? I need some padding. So I did what I called textile engineering and what is normally called sewing. So I made a pattern, and then I did more, and I did drafting, and I worked away. And then what I came up with at the end was that. And I call it the WebSphere Sphere. And it's the world's first Cuddly Throwable Application Server. So at this point, I sort of thought, well, very nice, but this is the stupidest idea I've ever had, right? Because there's not actually any commercial reason that anybody would want a throwable application server. And that's probably true, but does anybody want to guess what that is? It's a throwable microphone. I don't know if that was. So the idea is when you're giving a talk, people at large room, instead of having someone running around with a microphone, you can just throw the microphone. So it's kind of a similar technology, sort of, which I was reassured by, because it meant that it was only 90% silly, not 100% silly what I'd done. But the other thing to note about what I did was, some of you will recognize that as the WebSphere logo, and hopefully, maybe you'll see a similarity to what I did, but maybe you won't. Some people see it, some people don't. So the key thing about what I did is that it's a computer case, and that meant that it could protect the computer. But once the computer was in this case, there was a couple of problems. The first was that I had no idea what it was doing because it was in a case, and I couldn't see. So I connected some sensors to the outside. And the other problem I had was that there's a reason that we don't usually store our computers in well-padded cases while they're doing things, and that's because it's a pretty hot environment and there's no ventilation at all. And if there's one thing computers really don't like, it's cooking. And if there's one thing they tend to do to themselves, if you put them in a padded environment, it's cook. So it needed temperature sensors as well. And the temperature sensors are there for two reasons. One is to show it as a cool Internet of Things thing, where you can connect to the and you can see the temperature sensors. And the other is so that if I'm doing a demo, I know at what point I need to grab it back out of the audience and unzip it so that it doesn't cook. So to interface the ball to the computer, these are LED sequins, which are quite cool. And they light up depending on what's going on. If someone does a web request, it lights up. And the way they're connected, and this, I think I'm the only person who gets super excited by this, but it's really, really cool. You can make soft circuits. And so this is stainless steel thread. It's pretty cheap. You can sew it like normal thread, but you can also solder it, which is kind of a cool combination. And that means that you can do things that you couldn't do if you just had a hard circuit or if you had something that didn't have conductivity. So this is the moment of truth. And we should see, only slightly hopeful. You'll notice there it says running in emulation mode, all values are fake, because it couldn't talk to its pins, which is a little bit sad. And you'll also see it said started in 423 seconds, which is also slightly sad, because when I tell you that Liberty is so fast that it can run really well on a single board computer, 423 seconds kind of suggests that's not the case, but it's the computer is having issues, honestly. So after I finished that, it was a lot of work. I can show it to you, because it's set up here at the front. And what I'll actually do is I will pass it around, but it's still separate, so I won't throw it around at the moment, but I can pass it around and you can admire the tangle of wires and the non-functioning web server. I showed it to my mother and she said, why would anybody want an application server and a Cuddly ball? Well, it comes back to the throwable microphone. Probably no one ever would, but It's there. Who wouldn't want an application server in a cuddly ball? So I've got these slides, and of course at this point I don't actually know whether it worked or not. But my experience has been, in general, it is challenging to make it work. So the first problem I had with the PCDuino was that it would never connect to any display ever. So I had to do everything just by command line, which worked fine when it networked. And it was a bit of an unhappy experience when the networking was broken, which is quite a lot of the time. So I had a lot of problems with my wires snapping. And because they're sealed in a case, every time that happened, I had to take the whole thing apart. So that was quite unhappy as well. I had a lot of problems with batteries. The reason I chose a PCDuino was because it has onboard battery connectors. So I thought, oh great, this is going to make life really easy. But it turns out that the connectors on the PCDuino board are not standard connectors on any battery ever. So I had a lot of struggle where I worked out what connectors I needed, which is a JST connector, and only after I'd bought them and I tried to connect them together did I realize there's a JST PH and a JST SH, which if you know anything about connectors is really obvious, but if you don't, you just think the first 3 letters surely are the most significant ones. So that was a little bit of a challenge. And after I'd spent about a month, trying to figure out what had gone wrong, I finally found this page, which had been published after I'd had my experience, which says, oh, well, the board has this connector, and of course you won't find anything to connect to that connector. I was like, couldn't someone have told me that before? So, but it's okay, because I got a battery, I wired it in. In the one you've got the bottom layer is the battery unit, so it handles the mediation between the battery and the computer. So it turns out that the first battery that I wired in, I just wired it in straight, and the voltage was enough to power the computer, but not any of the sensors or any of the lights, because it turns out voltage matters as well. This is something that in high-level computing, we never really have to think about what voltage is. It's just like, it's a computer, it works, it's got power, or it hasn't. I hadn't realized that it mattered a lot. So then I used a USB battery, so that was kind of okay. But you can see that is a great big metal surface in the battery that I had. And there's quite a lot of pins there, so I had to provide some insulation layer, but it's okay, because I used a sock, and that was actually perfect. Yeah. So it's my new policy, is that all demos have to have a sock. So then I had another exciting problem, because 30 seconds before I was going to give a demo, the USB power connectors aren't really designed for high stress, it turns out, so I managed to rip it off. And of course, once you've ripped off the power connector, there is nothing that can be done. Except, it happened that there was a second power connector on that board. So it was okay until a month later, I ripped off the second power connector. So then what happened was it was still connected to the battery. That wasn't enough to power the sensors. And I learned a lot about electronics. And some sensors, the way they work is that if they expect to be fed 5 volts, and if something interesting happens, they drop their output voltage to 0. So when you read it, you assume that 0 is something interesting, and 1 is just, oh, nothing to see here, move along, which is fine when it's getting 5 volts as input. When it's not getting 5 volts as input, what it does is it says, well, I can't possibly give you a 1. Let me just give you a 0 all of the time. So what that means in practice was that it's got a sensor, and so when you throw it round, on the web page it says bounce. It uses WebSockets, it's very nice, but it relies on the bounce sensor working correctly. And when the bounce sensor is not working correctly, what happens is that, which just carries on, and then you get that. So the thing I like about this is I don't know if you can see my horrified expression as I realize what's going on, and the penny drops about what had just happened. So not done yet, because then it turns out that one of my sensors exploded. And I realized this because there was sort of a burning smell, and I was like, what is that? And then I turned the computer on and it didn't work, and nothing I could do would make it work. And finally I realized that if I unplugged the sensor, it worked, and it was because there was a short. And again, if you have a short in something that's connected to the main power unit, the effect is that you get no power ever and nothing else ever works. So I fixed that. I had to buy a new one. So then what happened? Well, then it turns out that having been thrown around for a year, my PCBino just gave up on life, and it said, I've had enough. I was not designed for this. Your padded case was not adequate protection, so I'm going to give up. So I bought a new one. And this is my mother again, and she said, I saw a video and I thought you handled the fact that it didn't work really well, but are there any videos where it did work? And I had to go back and I had to say, actually, you know what, Mum? There's not a single one where it worked, but then a miracle happened, and twice in a row it worked faultlessly, which was actually kind of unsettling, because I was going through the talk and I was like, and here's where, and it just worked, and all the sensors flashed, and I was like, oh, okay, fine. But really the problems I was having, a lot of them related to the physical world, because these things that when we do software just work, like having voltage and not having shorts, in the physical world, once you start to do that kind of thing, it just goes terribly, terribly wrong. But the other problem I had was that the physical world, unlike a cloud-based demo, doesn't fit in hand luggage. And so, particularly because it looks like a bomb. And it's a bit, I've had some uncomfortable experiences trying to explain why there's a sock and why there's lots of wires and lights and batteries, and it's just like, no, just not doing it. So I checked it, which was fine until I had a connecting flight. I don't know if any of you know, if that looks familiar to any of you, that is the lost luggage, what a lost luggage report looks like. So I went to Estonia and my luggage didn't, and so I had to give a very embarrassing talk when I said, I did a demo and it's somewhere in the airport. So the next thing that happened, if we're not tired of the catalogue of woe, is that you can't really see it, but the pins just completely snapped. So I had to do more late night soldering. I burnt the kitchen counter, which didn't make me very popular at home. Then the whole power thing died, so I bought a new one. And then it turns out that the battery also didn't appreciate being put next to things with pins and thrown around a lot. And I thought, well, there's a little bit of a hole under that tape, but that's okay, because, well, the battery doesn't give power, and that's a bit of a shame. But what could possibly go wrong? There's holes in batteries, no big deal, right? Well, apparently holes in batteries of that nature are a really big deal. And if you read on the further in that article, it's someone explaining how they had a hole and they thought it was no big deal, but they put it in the bin and the next morning their bin was exploded. So I bought a new battery quite rapidly after I got that, and it didn't arrive in time, so I had to buy new batteries. And then after all of that, last week I bricked my PCBino. So this was me this morning going to get the hardware I needed in order to flash it and debrick it. This was me at 2:54. What I didn't take a picture of because I was too unhappy about it was me at 5:20 with it bricked again. But then it sort of recovered, but as you could see, it only sort of recovered. So sorry about that. So every time I say, I'm not going to do it, I'm not going to do it. But then yeah. So should you be interested in pursuing IoT, for those of you who are interested in it, this is a tale of caution, which is that if you do it, you need a lot of money because you keep breaking your hardware. You need a lot of time because nothing works. You need a high tolerance for stress because nothing works. So, but it's all okay, because this is a lesson in resilience. Because every time it's gone horribly wrong, I've learned something new about the Internet of Things and something new about stress. So it's all okay. But just to wrap up, this has been sort of, well, hopefully fun, and it's been sort of fun for me, except for all the bits that were excruciatingly stressful. But in terms of us as technologists, as Java developers, is there a significance? Well, I think there is, sort of. Someone sent me this cartoon, and it was that moment when, I don't know if you have that, when you see one of these cartoons and you just realize it's just like described your life absolutely and then just punctured it. So what's going on here is he's saying, you know, he's describing all of the technical specs of the thing, and then he says, look, it's amazing. And at the end, the LED blinks, and everybody goes, wow. So you missed, because for various reasons, you missed the LED blinking. But maybe actually, hopefully that's not a hardship, because the really significant bits, sort of, are what we can do with single board computers, and the fact that they're so disposable and they're so accessible and we can use them for so many things. That is really changing what we can do with computing, and that's cool. Secondly, application servers. I think they were so big a while ago that I think a lot of us have a natural resistance, and we say, I'm definitely not going to use an application server for this. I'm just going to pull in 1,600 open source libraries and end up with something that's actually a bit bigger than an application server and a lot harder to manage. Well, do think twice about doing that, because application servers really have changed. They're a lot lighter than you think, especially things like microprofile, which are designed for microservices, designed to be a really compact package that's just what you need, designed to work together, so a good thing. And finally, Java EE, again, I think has a bit of an image problem since about 2001, when it was really bad. It's not like that anymore. It's really nice. It's all standardized, so you know you have the portability between different vendors. It's annotation based. You add the one annotation, it all just works. So definitely worth looking at that standards-based way of doing things, because I think it does solve problems. So I will leave it there, but thank you very much.